Welcome everyone. We are gathered here to have Rook Storage for Kubernetes talk. I'm Deepika Upadhyay from Clyso. I have been working with Rook Ceph for almost 5 years now. Madhu?
Yeah. Hello, I'm Madhu Rajanna. I work for IBM. So I'm one of the maintainer of Ceph CSI, Ceph CSI operator, CSI add-on. Also take care of integrating CSI with Rook.
Yeah, hello, I'm Artem, also working for Clyso, joint project last year, mostly working on object storage part.
Hi, I'm Travis Nielsen, one of the original creators of the Rook project. Happy to hear and talking more about Rook.
So to get started, we'll have the agenda for the day is we'll have a short introduction to Rook and Ceph. Then we'll look into what new features are added to Rook. Then we'll have a short overview of Ceph CSI driver. Then a major use case for Rook, which is object storage. Lastly, we'll see what maintenance considerations you should have while working with Rook Ceph. So to get started on introduction to Rook, where did it all begin? So coming to the question, if you are using storage for Kubernetes, you generally go for the cloud providers, but why not have the storage in your data centers? Why the storage is not as scalable as the applications you use? Is there even a storage solution that's doing it? So with that question, we begin to design a storage platform. And the considerations we had was we didn't want to reinvent the wheel. We just wanted to have the best way to run storage in Kubernetes. And for that, we chose Ceph, which has been running in production for almost a decade now. So looking into what Rook is, Rook essentially is just a Kubernetes operator that automates Ceph storage for you. It's completely cloud native management, so you can use CRDs for handling deployment, scaling, and management of storage. It's easy to consume. You can use PVs, storage classes, and also have CSI driver for access. And it's completely open source. So looking into how the architecture looks like, it has three layers. The first one is Rook, which deploys and manages Ceph storage. Then we have CSI, which mounts and provisions storage for you. And lastly, and we have Ceph, which is the data layer where your application's data is getting stored. So the question comes why we chose Ceph. It's an open source distributed storage solution complementing well with Rook's philosophy, and it really ticks all the boxes. If you see, you want to have block storage, you can have that. You can have shared file system. You can have S3-like object storage. And adding to that, it's very scalable. You can scale up and out very easily without any downtime. It's thin provision, so if the storage capacity used would be based on actuals and not on how many PVCs you are creating. So looking into the scalability numbers, we have seen multi-petabytes Rook cluster already, with the recent cluster reporting around 250 nodes used, 1,800 OSTs, each having 3 terabyte of NVMEs amounting to around 5.2 petabyte storage. And if you see the Ceph public telemetry numbers, it's already reaching exabytes. And that's not just, the numbers can be many times of this because few people enable public telemetry. And Ceph is also very performant. If you configure it correctly, you can see the blog for more details. It's already reaching to 1 terabyte per second speed as well. And now you have a complete solution using Rook and Ceph. Where can you run it? Short answer is anywhere Kubernetes run. So you can run it in a cloud provider environment with using EBS or persistent disk, or you can have your own on-prem bare metal data center using it with SSDs and HDDs for more performance and control. Or you can also have a hybrid and multi-cloud environment, mix match for storage across cloud and on-prem for resilience. And if you see the advantages of deploying Rook in cloud environment, the challenge people generally face in cloud environment is they fear data loss as there are no availability zones. Rook replicates and distributes storage data across AZs for you. And there can be limitations on the persistent volumes per node in some of the cloud providers, or there could be poor performance of small PVs. Rook has an intelligent and optimized object store data placement, and it virtually gives you unlimited scaling. And you can also have cross-cloud support. As you see in the next slide, you can have an external Rook Ceph cluster and have your Kubernetes client clusters accessing this unified Rook Ceph Kubernetes cluster for storage demands. And looking into the new features that we had a recent release in December 2024, 1.16. With this, we have mirroring now available for RDOS namespaces. There were improvements in object storage with S3 storage class improvements, and you can also access audit logs for S3 now. And we have now direct multis network integration, so no more holder pods needed. We also support Reef and Squid Ceph versions. And in the next release that we plan, 1.17 in April 2025, we want to have CSI operator enabled by default, allow Rook operator to run in multiple namespaces independently, and support multiple Ceph clusters. We want to have Ceph CSI version 3.14 integration, and have some object bucket claim improvements planned for greater control over buckets. We also have external monitor support for 2 data center scenarios. Also, we plan to support Ceph's latest version, Tentacle. And if you want to download and get started with using Rook, you can use a helm chart or latest release from Docker, Quay, or GHCR. Now, in the next slides, we'll cover CSI driver. Over to you, Madhu.
Thank you, Deepika. So let's talk about CSI driver. Like CSI driver, like we host 3 projects, basically 3 drivers in it. Like one is CephFS, RBD, and NFS. So it's a single project which holds like 3 drivers together. So this is the architecture looks like. We have like a controller plugin which runs as a deployment, and we have a node plugin runs as a daemon set. The deployment runs with like HA. It's always like replica 2, which is responsible for volume snapshot, group snapshot, creation, deletion, volume expansion, all that stuff. So whenever you want or wherever you want to mount the PVC to your application, we need to run the node plugin pod that is responsible for mounting and non-mounting the PVC. They run like as a daemon set, 1 per node. There are like few key features of CSI driver. Like we CSI driver, like we use OMAP extensively for the state maintenance in Ceph CSI. Even if it restarts, like we don't want to leave any garbage values. So we use GoCeph for the API calls to talk to Ceph to get a better performance because they reuse the connections which is connected to a pools. So a single CSI driver is able to talk to multiple Ceph clusters. We don't need to run CSI driver per Ceph clusters. So we have an isolation at the Ceph level, like we could use RDOS namespace as a volume group to get a multi-tenancy as well. There are like, we support thin provisioning. For RBD, we support RWX block mode. This is for VMs. We support RWO file system for databases. For CephFS, we support RWX file system. And NFS, we support RWX, which is on top of CephFS. We support PVC encryption for both CephFS and RBD. We have tested with various KMSs, like such as example, Vault, Azure, like IBM HPCS, like bring your own key, secrets, etc. So we also support online PVC expansion for all the 3 drivers. We support volume snapshot for CephFS, RBD, and NFS. We recently added support for volume group snapshot for RBD and CephFS. The PVC clone is supported for all 3 drivers. So there was some problem with CephFS backups because CephFS clones are like costly operation. It's full copy. So we implemented something for specifically backup tools where they can clone into an ROX. So they can just mount and copy the data to some remote site. So this was one of the use case solved for CephFS. We support topology-based provisioning, like we read from the nearest OST so that we get better performance. We support static provisioning, entry migration as well. We support kernel mounts and the user space mount for both CephFS and RBD. So we have everything with CSI. So we need something on top of it, like suppose like in Ceph we have replications, etc. So we built something similar to CSI. It's called CSI add-on. So it runs in a similar manner where we have one controller and a sidecar running with a CSI driver. So in RBD, like when you delete an file from a PVC, so the in the backend, the space will still be occupied. So we have built a Kubernetes VF mechanism, like user can create a CR. So in the backend, we run FSStream or RBD Sparsify to just make sure like we have a balance between the data and like what you see on the user and the backend. We support network fence class. This is like recently added one where like on all the nodes, like we will display like what's the IP visible on Ceph cluster. This is very useful for disaster recovery, especially for RWO PVCs where they want to move to another node. So we don't want to have any problem with the data. And also it's useful for like where you want to move your application from one cluster to another cluster. So you can fail over, fence the whole cluster, and you will have a data. So we support like PVC encryption for CephFS RBD. We added a key rotation policy as well, where like user can run like kind of a cron job for rotating the keys for the encrypted PVCs. This is one of the important features for CSI add-on, that's volume replication. We support replication of a PVC and replication of a group as well. So this is like Kubernetes way, like we have a CR, so you don't need to do any manual steps in Ceph, like to promote, demote, and all the operation. Just one state, change it so that you will be able to do the disaster recovery from like one cluster to another cluster easily. So we have CSI operator. So we want to move away the like all the CSI functionality or the maintenance from Rook to CSI itself, so that we expose the CR for the user, so that with a minimal configuration you could have your own CSI drivers created. We support Helm installations and Kubernetes charts as well. Some of the future roadmaps for CSI driver is like we plan to support NFS shallow volume as well, because NFS uses the CephFS underneath. We have the same problem. We have planned to support browse authentication for NFS volume. So a volume group snapshot for RBD, though it's supported with upstream main Ceph. We are waiting for a release as well to make it a GA feature. So we support mirroring for group snapshot. We are working on chain block tracking for RBD PVCs for better backup. We have planned to support QoS for RBD PVCs as well. This is one of the long waiting feature. So I'll hand it over to Artem to talk about object store.
Yep, thank you. Object storage. Ceph implements object storage in Rados Gateway application, or RGW. RGW is a web server implementing S3 and Swift protocols and using Ceph as a storage layer. In a simple case, user defines Ceph object store custom resource with desired number of RGW instances and parameters for Ceph RBD pools, and Rook will create RBD pool in Ceph and RGW deployment in Kubernetes. Another advanced scenario is a multi-frontend deployment. It allows to have dedicated RGW deployments with different configuration, but serving the same data. For example, have a separate deployment to host only S3, only Swift or admin APIs, have a dedicated deployment per customer for better load balancing, or a dedicated instance to perform garbage collection. In this case, it will be disabled for user-facing instances for performance reasons. Here you can see object store custom resource with a long list of parameters, which can be divided in two groups. The first one is a front-end configuration. It configures deployment like desired number of replicas, resources, enabled protocols, also certificates, domains, and so on. And the second group is a backend config telling where and how store data in Ceph. Rook allows to move a backend configuration into separate custom resource and refer it from object store. And this way, we can have a second object store using the same backend. For example, one on the left hosts only S3 API, and the second one only Swift, but the same data. So you will be able to access objects from the same S3 bucket or Swift container. Now let's explore advanced backend configuration, specifically pool placement and storage classes. So here is again Ceph object store custom resource with the backend configuration zoomed in. You can see a list of pool placement. Each placement has a name and a set of pools. The first one is metadata pool. It's responsible for storing bucket index and metadata. We configured pool to store it on SSD in 3 replicas. We also have a data pool storing object payload on HDD in 3 replicas. And we also defined storage class reduced redundancy and override data pool with HDD single. It's also storing object payload on HDD, but only in a single replica. Now, S3 clients can create bucket and refer our placement as S3 region. And if user, for example, put an object in such bucket, it will end up in HDD 3 replica pool. And if user set storage class reduced redundancy, it will be stored in a single replica. Rook allows to have any number of pool placement and any number of storage classes per placement. Now let's see how Rook provisions object storage to other Kubernetes applications. The most popular way is to use object bucket claim. It's similar pattern to PVC. Here user creates object bucket claim with the storage class name, bucket name, and optional storage quota. Then Rook creates actual bucket and credentials in Ceph and provides secret and config map with connection information. Another way is to use container object storage interface or COSI. It's open specification currently in alpha version. It defines how orchestrators like Kubernetes can provision storage from providers like Rook or, for example, cloud providers like AWS. It defines admin custom resources, bucket class, and bucket access class, describing storage quality of service and access permissions. There is also user custom resource to actually request the bucket and access for it. And finally, Rook also implements COSI driver, creating bucket and credentials and creating a secret for application to connect the bucket. Now, Travis.
Okay, thanks everyone. So we've heard a lot about the features of Rook. Storage is a huge topic too, and we're just scratching on the surface. But one thing that's really important to know is that, of course, your data is important, it's critical, and Rook does everything, and Ceph does everything we can to protect your data. So it's important to understand, well, what do you need to do as system admin to make sure the data stays safe? What do you need to think about during your cluster maintenance tasks? Because it's not something that you can just deploy and expect to work indefinitely. It takes some attention and some planning. So as you're doing your maintenance operations, you need to maintain the nodes, you need to update Kubernetes, you need to do this and that. So what can the cluster survive? What can I take down? And what will keep running? What can I expect at my data layer to keep running? What's the severity of my outages if something goes really wrong? And what can the cluster survive? And one of the basic things that's important to configure then and plan for is your topology in the cluster. So your topology being, how do I lay out my data center? Do I have multiple data centers, zones, racks, hosts? How many devices per each node? There are lots of ways to do it, and I'll just touch on some of the considerations today. So this picture shows us a zone topology where, okay, generally you'll have 3 zones. You need at least 3 zones. You can have more. And within each zone, you can have multiple hosts. And each of those hosts can have multiple OSDs, where one Ceph OSD maps to a single disk. So as you place your data in the cluster, generally you'll configure with 3 replicas. That's the default recommendation. So Ceph will place 1 replica of the data across each zone. If you're running in the cloud, that means you get a replica across each zone, and the data is available from any of those zones, as Deepika touched on earlier. And so what happens now as maintenance operations need to happen, as things go down? What can we survive? So let's say we need to do maintenance on a zone. There's a network outage in a zone. There's something that needs to happen in one of the zones. And let's say everything in zone A goes down, what happens? Well, from your data perspective, the cluster is fully online. Ceph is able to still serve the data for reads and writes, and everything will be working and staying online. So there's no downtime, there's no outage, there's no data loss, even with having a full zone that is down for some time, or even permanently. No data loss, no downtime. What if it gets worse? What if we have an outage where 2 zones go down? This is where, because the data is replicated across all 3 zones, the data itself is still safe. So zone C still contains all of the data. But what does this mean for availability? Where the cluster is down, no writes or reads are allowed at this point. So you'll need to get one of the zones back online in order to bring the cluster back online. But at least the data is safe. And there are measures you can take to bring the cluster back online with that single zone if the other 2 are completely lost. But that's how you know the data is safe, as long as the data on one zone is safe. So for your various maintenance operations, how do we help guide this process? So pod disruption budgets are Kubernetes' method for signaling how much can I take down at a time. So Rook will manage the PDBs dynamically to say, oh, it looks like you're draining this node. Let me adjust the pod disruption budgets so that I'll allow any node in that zone to go down. So back on this picture here, if we see you're draining host X, Rook will adjust the PDBs to allow host Y to also go down at the same time. The PDBs, however, will block zone B or zone C from going down at the same time, so that while you're doing node maintenance, as long as the PDBs are respected, you won't expect any downtime during those maintenance operations. So the PDBs are topology aware, and the PDBs will help guide you through that to keep availability. Another type of maintenance is when you're upgrading. So if you're upgrading Rook itself, Rook will do it in a rolling manner. So rolling upgrades automatically so that you don't have any downtime, and it's only at most one failure domain affected at a time. So here's kind of a case study. So in the last month or so, working with a user where kind of the worst case scenario, during one of their maintenance operations, the control plane and all the worker nodes were accidentally imaged. Oh, whoops, I just rebooted all my nodes and they all got a new image. That's rather disastrous. Kubernetes is gone, right? So what do we do? Is there any hope to recover the data? Well, the data is persisted to disk by Ceph. And so the question became, well, how can we get the data back from the disk? Even though Kubernetes and all its metadata is completely lost, how can we bring it back up? Well, in this case, we were able to help them with a lot of manual operations, admittedly, to be able to get their data out, their critical data they were able to bring back up from the disks that were still available, bring up basically a temporary Kubernetes cluster, mount just the device's RBD or CephFS volumes that they needed, and extract the critical data. So we're working on documenting this case and adding it to our Rook documentation so that if anybody hits this case, it is possible to recover. We do have some steps in this already in our disaster recovery guide in the documentation, but there's plenty of room for improvement, and we're clarifying that. So as far as tooling, what can you do during your maintenance operations? We do have a kubectl plugin, which is essentially a CLI tool for running different maintenance tasks on your cluster. These are things that don't really fit the model of CRDs, where you need to do a one-off maintenance task instead of expressing desired state in the CRDs. So there are things like you've got some downtime, you need to restore Moncorum to that single zone that is only remaining. You might need to remove OSDs, you might need to perform other maintenance operations for advanced things with Monzo OSDs. And if there are other maintenance operations that you've seen you need to run in your cluster, we'd love to know, well, what would you like to see automated? Because this tool is the perfect place to run those one-off tasks where if it's not a CRD setting. And just to finish up, I want to talk about project health. Well, how does the Rook project work? How do we value the community? Well, really, since the project was started, I think we're coming up on our 9th anniversary now. Amazing it's been that long. But community's always been important to us. We've got over 400 contributors to the project. Out of all those, I forget how many thousands they said in the keynotes this morning to Kubernetes, but had a lot of downloads. We graduated. CNCF graduation is almost 5 years ago now, in 2020. And thanks to all our contributors, we've got currently Clyso, Cybosu, IBM, and Red Hat and Upbound as contributing with maintainers. And we're always looking for new maintainers. If you get involved in the project, we have a process to advance maintainers and those who are active in the project. The stability, being that we provide a data plane, stability is, of course, critical. So we declared Rook stable 6 years ago. There are many upstream users running in production, many downstream deployments and products running on top of it as well. So just happy to say it's great to see so many people running it in production. How often do we release? We do have a minor release about every 4 months, kind of to follow the spirit of Kubernetes itself, which releases about every 4 months. We do have the 1.17 release planned in the next couple of weeks. And just to have a cadence of patch releases, about every 2 weeks we will release a patch, or on demand if there's a critical need. What's our roadmap for Rook? Well, essentially, sometimes we try to say, well, here's a feature list, here's what we want to do, but ultimately, our philosophy is we always want to support the latest Ceph features that the data plane is providing. We always want to make sure we're integrated with the latest Kubernetes features, as there are always new features coming out, and to make the Ceph the best storage platform for Kubernetes that it can be. As Kubernetes keeps growing and growing, we've seen everybody needs storage, and they need it to be the best it can be. If you're still in London in a couple of months, there is Ceph Days. Here's a link to go register for that. And then I think we've got some time for questions. So thanks, everyone. Please come to the Project Pavilion. We do have a Rook booth for the first half of the day until 3 p.m. today, for example. So come find us there, and we'll be there, happy to answer questions if we don't have time right after this. So thank you.
Anyone?
The mic is walking around. We've got one in front here.
Hi, thank you for the talk. Noob question, but what's the performance penalty compared to running like just a local storage compared to running it in Ceph with Rook in a container storage?
Mm-hmm. So the performance of local storage, just the local disk compared to running with Rook and Ceph?
Yeah, like the throughput and maybe the latencies also because of this distributed. It probably has a penalty hit.
Yes, so with a local disk, of course, you don't have any latency with network or other things, so that will be the highest performance of a local disk. But yeah, when you introduce Ceph, where you've got multiple replicas being replicated to other nodes, Ceph is fully consistent, and so it does require committing to at least 2 of the 3 replicas before it will act any writes. So so there's a network performance to write to at least 1 other node and even 2 nodes. So there is a performance there. It depends exactly on the numbers as far as your hardware and network, and we don't have numbers published because there's so much variety in that performance. But I don't know, does anybody else want to comment on that? Or
There's a blog linked in the presentation as well. You can take a look into how to get the performance number for your use case. You can use FIO. You can have benchmark the local disk and then run FIO with maybe RBD or the workload, and then see the numbers for yourself. Yeah.
Thanks.
yeah, another comment on that also is that Ceph is, as a distributed file system, essentially a distributed storage. It works best when there are many clients, because many clients can distribute the load across many nodes. So the bigger the cluster, the more clients, the better overall throughput you'll definitely see. If you just have one client, yeah, you're not going to be as impressed with the performance probably, but the bigger things are, that's where it shines. Oh, is that about time? Okay.
One more?
One more? Yeah.
I have a question to your case study. So if only the Kubernetes cluster is nuked, but the data is still available on the disks, wouldn't an etcd backup be enough to get the data back? Because you theoretically spin up a new cluster with similar number of nodes, and then with the etcd backup, you could be able to recover the Kubernetes resources you need to get the data.
Yes, correct. With that, if etcd is backed up and you can essentially bring back Kubernetes, then it's a much simpler recovery problem and not difficult. In this case, they even, if they had an etcd backup, they couldn't recover it. Something went completely wrong with all etcd backup. But that, yes, that will improve your life, definitely, if you can back up etcd and restore it in that case.
Okay, thank you.
Okay, if no other questions, feel free to come up and we'll be here for a few minutes. Thank you.